Hello class, this is the video for section 5.3 exponential functions. Following our learning objectives, evaluate exponential functions, graph them, define the number e, and then solve what exponential equations, including what applications. Okay, so we'll be talking using some one application problem. All right, now first example, we want to evaluate using a calculator to evaluate the following what exponential functions. Now, exponential function, if it's of the form, okay, f of x is of form either a raised to what x. Okay, now in this case, my a, which is the base, okay, a is the base, is equal to what 3, and then the x varies. All right, so for my calculator, I have the TI-83, all right? And so if I want to evaluate, use it to evaluate the 3 raised to 1.7, okay, I go and punch 3 first, okay, I go and punch 3, and then I use this key, all right, which is like that, then raised to 1.7, and then I enter. And then that should give me 6.473000784. Okay, and I do the same for B. It is 3 raised to what? 1.73. Okay, that gives me the value. And then when I keep going, 3 raised to 1.732, that gives me that. Okay, 6.704617,606. And then if you have 3 raised to square root of 3, all right, that should give me this value. All right, so we have a calculator. We can use this. Now, we can change the a to the base, okay? Like we said, the f of x, the functions of form a raised to what is right. And there are two occasions that we're going to, we want to call this is the exponent, okay? And then the a is what? A is your what? The base. A is called the base. That's exponential function. Okay. Now a is a real number. It's actually a must be greater than what? Must be greater than 0. All right. A must be greater than 0. Okay. Even if it's 1, okay, if it is 1, it's greater than 0. So it could be between 0 and 1, it could be a fraction for any value like that. All right. Okay. Now this is a review of the laws of exponents. All right. That if you have the S, T, A, B, these are real numbers, and your A is was greater than 0. And then B is also greater than 0. All right, talking about the bases. Okay, then A, if you have the same base, you add what? You add the exponents. Okay, A raised to S times A raised to T is what? A raised to what? S plus what? S plus T. Now A raised to 1 raised to any value. Okay, 1 raised to 0 is 1. 1 raised to 20 is 1, like that. Then when you have a raised to s all times all raised to t, then you multiply the exponent, so it becomes a raised to what? S times what? T. Then if the bases are different, a times b raised to what? S, that means just raise each of the base to the s and then multiply them like that. Okay, and it's important to know that anything raised to 0 is equal to 1. And so if I have 20 raised to 0 is equal to 1. And then finally, if you have a raised to negative x, we don't usually want to have what? The final answer, we don't want it to have negative exponents. And so we're going to write this as 1 over raised to what? Raised to s. And then, which is the same as well, 1 over a all raised to what? Raised to s. Okay, so if I have like 3 raised to minus 3, this becomes 1 over what? 3 raised to what? To the third. Or this is the same as 1 over 3 all raised to what? Raised to the third. So basically, this is 1 over what? 27. Okay, let's take some quick examples to apply this to simplify. Okay, now this is the same. We don't want to have negative. So if they write them like that, they have the same base. So use one of the properties says that this would be 7 raised to what? Negative 6 plus 5, which is equal to 7 raised to what? Minus 1. And since we don't want the final answer to have a negative exponent, we're going to write this as 1 over what? 7 raised to 1, which is what? 1 over what? 1 over 7. Now for the B, okay, see, we have what? X and Y have a different basis, but each of them raised to a certain number. But everything raised to negative what? Negative 2. So if we apply, then this will be what? X raised to the 4. One of the properties we have what? Raised to what? Negative 2. Then times Y raised to negative 3 times what? Negative 2. Okay, so when you simplify that, this becomes what? X raised to 4 times what? Negative 2, that is negative what? 8 times Y raised to negative 3 times negative 2, which is what? Positive 6. Now we don't want to have a negative exponent, so we're going to write this as what? Y raised to what? 6. Okay, that'll be 1 over 8, times what? 1 over X raised to what? Raised to 8, which becomes Y raised to the 6 divided by X raised to what? Raised to 8. Okay, now we don't want to have a negative, so we're going to move everything in the denominator, the C, and to the numerator. All right, so we're going to write 2 to the what? To the third times, since this is 2 to the second power, that becomes 2 to the negative 2. Then times we have what? 3 to the second times 3 to the what? Negative what? 5. Okay, so when you add the exponents, the bases are the same for the 2. That becomes what? 3 raised to 2 raised to what? 3 minus 2, which is what? 2 raised to 1. Then times 3 raised to what? Negative 3. Of course, we don't want to have a negative exponent, so this becomes what? 2 times 1 over 3 raised to the third. And that is what? 2 over 20 what? 27. Okay, and that is your final answer. Now to get more of this, more practice, please go to see the appendix A1, okay, and look at all the pages A1 to what? A11, and you see more examples and exercises there to go over this. Okay, laws of exponents that you did in Math 96. Okay, so now let's define the exponential growth function. All right, the exponential growth function is of the form f of x is equal to c times a raised to what? Raised to x. Okay, where a is positive, okay, is greater than 0, and it's not equal to what? It's not equal to 1. All right, so we want to make sure that this what? A is greater than 0 and a is not equal to what? Is equal to 1. Why? Because if a is equal to 1, anything raised to 1, it doesn't change. It's the same 1. Okay, that's why a, even though a is greater than 0, but it's not equal to what? 1. All right. Okay, what's the domain? Is what? All real numbers. The base is what? A, and the growth factor, okay, A is the growth factor. That's the A, that's the base, is what we call the growth factor, because f of what? 0 is equal to c, and this is called the initial value. All right, so wherever x is 0, the value of the function when x is 0 is called what? The initial value. All right, again, your base is what? The growth factor. All right, so now there's a theorem says that for any exponential function, all right, c times a raised to x, all right, a greater than 0, not equal to 1, and c not equal to 0. If x is any real number, the ratio of consecutive outputs is what? Is constant. That is, if I plug in the function, if I plug in x plus 1, which is the next divided by the previous output, it is equal to what? It's equal to the a. Okay, which is what the growth what factor. Or if you multiply this out, cross multiply, you get what this kind of what equation. Now C is called the initial function value when what x is equal to what 0. So take note of that. All right, so let's take example. This exercise number 2. We are given a table, all right, A and B. We want to determine, okay, whether this function that models this output is a linear or exponential or neither. Okay. Now, for those that are linear, we'll find a linear function that models it, and then for the same forward exponential one. Okay. So how do we determine whether it is a linear, that's a linear equation, or it's what exponential or neither? All right. Now, for each function that we have there, okay, if it's linear, we're going to calculate what we call the average rate of change, okay, of x with respect to x. And then we also find the ratio of the consecutive outputs. Now, if the average rate of change is constant, then we know it is linear. If it is the consecutive ratio of consecutive outputs is linear, then we find we say that is exponential. Okay. So first, let's look at exercise, the part A. Okay, these are the values of what is a table. X is equal to 1, y is 6, 0, y is what? 1, and so on. So how do you find for each of them, we're going to do average rate of change. Now, if you remember, average rate of change that we did in chapter 2, okay, it's coming back again, all right? It's a change in y over what? Change in x. So we look at the first two, all right? What is the change in x over change in y? Which is the y, y2 minus y1 over x2 minus what? X1. So remember, that's the rate of change. Okay, so we have 2 minus 6, and then what? 0 minus 1. That gives me what? Negative 4. Okay, then between these two, okay, my y2 is what? Negative 2. My y1, x1 is what? 1. Y1 is what? 2. My x1 is what? 0. So we do the same thing. Negative 2 minus 2 over 1 minus what? 0. And that gives me what? Negative 4. So we do it between these two pairs of what? Other x and y values. And then lastly, we have that. So you could see that we have what? Negative 4, negative 4. This is what? Constant. Okay. Now let's look at the ratio of the consecutive outputs. So we are dealing with what? Only the y values. Only the y values for this one. That's the outputs. Okay, so between 6 and 2. All right. This is the first one. This is the second one. So it will be what? F, remember, it's what? F of x plus 1 over f of x. Okay, so f of x plus 1, this case is what? It is 2 divided by what? 6. That gives me 1/3. Then between these two, okay, this will be negative 2 divided by what? That's why I have negative 2 divided by 2, which is what? Negative 1. All right, and then repeat it between what? These two, and then lastly, that 2. And you can see that this is not constant. This is 1/3, negative 1, this is 3, 5 over 3. So that's not constant. So this is what? Part A, it is what? It's a linear. It is linear because the average rate of change is what? Constant. Negative 4, negative 4, negative 4. So it means we have to find the equation. All right? Okay. Since that is the case, the average rate of change, which is what? The slope. So the slope of the line is what? Is negative 4. Now, if the slope of the line, then we need to find the what? The y-intercept. So what we do is that we just pick any of the what? Any of the, sorry, okay? We just pick any of these pairs. Either I use what? Negative 1, 6 or 0, 2. It doesn't matter, okay? Because these are points, all right? You have minus 1, 6 is 1 point. 0, 2 is another point. We have 1, 2 is another point, like that. Okay, so you can use any of them to find the what? The y-intercept. So if I use the ordered pair, which is 0, 2, okay, x is 0, y is what? 2. What is that? That what is the b? Well, we know that it is y is equal to mx plus what? Plus b. So in this case, this is y is equal to minus 4x plus b because the slope is what? Negative 4. So if I plug in 2 equal to negative 4 times 0 plus b, the b is equal to what? Is equal to 2. So then we know that the function that models what is linear and is equal to minus 4x plus what? Plus 2. Okay. So in other words, your f of x is equal to negative 4x plus what? Plus 2. So that is linear. Okay. Now let's go to this b part. We're going to repeat it. You find the average rate of change and then what ratio of the consecutive what outputs. Just like we did. Okay. Average rate of change for the first two pairs will be what? 27 minus 81 divided by 0 minus 1. That is negative what? 54. The second pair will be negative 18. The third, negative 6. And then the fourth is what? Negative 2. It's not constant. So this is not linear. So let's look at the average rate of change. So ratio of the consecutive outputs. Well, this will be what? 27 divided by 81. We get 110. 9 divided by 27. We got what? 1/3. 3 divided by 9. We get 1/3. And then 1 divided by 3, which is also 1/3. Okay, so we see that that is constant. Looking at these values here, everything is what? Is the same. So this is going to be exponential. So that means we need to determine what is c. Now exponential function is what? Is c a raised to what? X, where a is not equal to 1, a is greater than 0, and the c is greater than 0. Well, what's the c? Now I want you to look at this pair. C is what? When the x is what? X is 0. Okay, so when x is equal to 0, we have what? That is f of 0 in this case is c a raised to what? 0, which is what? That. So in this case is equal to what? 27. Okay, so my initial value in this case is what? 27. Okay, so for part B, all right, the what do you call it? The ratio of the considered outputs is what? 1 unit increase in the inputs is what? We got what? 1/3. And this is my what? This is my A, the base. Okay, that's the base. So if I want to write a function, okay, it's exponential function. The growth factor is the A, which is that. So what is the function? All right, what is the function? Now we know that this is the g of x. Okay, is c a raised to what? A raised to x. Now we know a is that. So this is equal to c 1/3 raised to what? Raised to x. But what is the c? As we mentioned, c is what? We are calculated that to be 27. So therefore, the growth, exponential growth in this case, what? 27 times what? Times 1/3 raised to what? X. Now remember, this is the same as 27. And then you can write it as what? Minus what? Minus 1 all raised to x, which is the same as 27 27, and then what? 3 times 3 raised to what? Negative what? Negative x. Okay. All right. Now we can simplify this further because 27 is 3 raised to the third, and then you can add it, but we're gonna end it here. Stop like that. Okay. So now let's look at the properties of exponential function. All right. Now remember, we said generally we have what? F of x is equal to a raised to this. A is greater than 0. A is not equal to what? It's not equal to 1. Okay. A is not equal to 1. So if we have the case, there are two cases. A, you have what? You have A is greater than 1. And then B, where A is what? Is less than 1, but it's greater than what? 0. So each of these, one of the functions will be increasing, the other will not be decreasing function. So we're going to consider the first case where A is greater than 1. Your base is greater than 1. So for something like, you have f of x is equal to 2 to the x. Okay. Now this is general, and this kind of graph works for any exponential function in this form where what a is greater than 1. Okay. Now the graph will pass through what? The point 0, 1. That is the y-intercept. And then when x is what? X is 1. Okay. You already have a 1. The pass to the point 1a. And then if it is negative 1, you have negative 1, 1 over what? A. If you have negative 2, all right, then that point will have these coordinates. All right. It will have the coordinates negative 2, and they have a squared. Okay, like that. If it is 3, it's going to come down. Now you can see that this doesn't touch what the x-axis. So this is what? That's the line y equal to 0 is a horizontal asymptote. Okay, this is an increasing function. As we move this way, it is what? Increasing. Okay, and to pass through these 3 points. So for example, if I want to graph this, f of x is equal to 2 raised to what? X. Okay, this is be the graph. Okay, this is 1, 2. Let's just do just these two, negative 2, negative 1, and 1 and 2. It's going to pass through this point. Okay, if x is what? The intercept is going to pass when x is 1. Okay, when x is 1, it's going to pass through what? This is 2. Okay, if x is 2, that will be what? That will be the point. This is what? 1a, which is what? 2. And then when x is 2, this point will be 2 to the squared. And then it's going to pass through this. This point is you're going to half of that. This point it will be, and then we have this point. Let's write it here. This is what? Negative 1, 1 over 2. And that is what? Negative 2, 1 over what? 1 over 4. Okay, so the graph is going to pass to these points like that. It comes down and never touches what? The x-axis. Okay, that is x, and that is what? That is y. So what are the properties? We can find the domain. It's all real numbers. The range is anything greater than what? Greater than 0, and so on and so forth. So what are the properties? The domain is what? All real numbers. Okay, now the range is what? From what? 0 to what? Positive infinity. From that graph, okay, it has no x-intercepts. Okay, the line horizontal asymptote is what? The line y equal to 0. And this is an increasing function, and it is 1 to 1. All right, let's go back and show why it is 1 to 1. Well, it is a function because it passes the vertical line test. Okay, it is also 1 to 1 because it passes the horizontal line what? Horizontal line test. Okay, and then the graph contains these points as I've explained. Okay, it's always going to pass through that, and it is smooth and continuous with no corners or gaps. All right, so we have the picture. You don't worry about it. This is the one I just showed you before that. All right, so then we have to consider the case 2 where a is what? Greater than 0 and less than 1. Okay, that is going to be this. There's going to be a decreasing function when your a is on something like they have f of x is equal to, say, 1/2 raised to what? Raised to x. Okay, which is the same as what? 2 raised to what? Minus x. Okay, so if you have this kind of graph, it's going to be a decreasing function. Okay, it's going to pass through the same point. All of them will pass through the y-intercept 0, 1. Okay, and then when x is negative 1, it will be 1 over what? 1 over, what do you call it? 1 over a. Now you are thinking, in this case, my a is what? 1/2. So if I have 1 over a, sorry, I have 1 over a, what would that be? This would be 1 over 1/2 which is what? Which is 2. So that's why at this point the y value is higher. So don't be deceived, because 1 over a is a fraction between 0 and 1. And so 1 over that reciprocal will be a bigger value. All right. So it's going to pass through this. Again, the horizontal asymptote is what? The x-axis, and this is a decreasing function. And so if I have this graph, let's say f of s is equal to 1 over 2 raised to what? X. Okay. It's going to pass through the point. Okay. This is going to be this point is be 1 over 2. So that'll be, this is 2. So it's going to be here. And then if it is negative 2, that will be like 4. Okay, this is 2. And let's say this is 4. That would be this point. And they have 1 and 2. This would be 1/2. It's going to pass through that point, coming that way. So it will be a decreasing function like that. Okay, the coordinates of this are, this will be 1 and 1/2. And then this is going to be, this point will be what? 2, 1 over what? 2 squared, which is what? Which is 4. Okay. And that point, I've explained there, this will be negative 1 and 2. And this is what? Negative 2 and 4. All right. So that is an example of that. Good. Okay. What are the properties? The domain is all real numbers. The range is the same. Okay. No x-intercept. Horizontal axis is the x-axis, your what? The horizontal asymptote. Okay. It's a decreasing function and it's 1-to-1. It passes through these points, and then the graph is smooth. And then this figure is what I showed you in the previous slide. Okay, so forget about that one. All right, now let's go to graphing exponential using what? The transformations that we have studied before. Okay, in chapter 3, part of chapter 2 and then chapter 3. So you could see that it's transcending through all the transformations that we considered. All right. So we want to determine the domain, the range, and then the asymptote and y-intercept for this graph. So we're going to go through the steps. Okay, the base function is what? Y is equal to what? To the third. So when you graph this, all right, same as before, when it's going to pass through what? 0, 1. And when x is 1, it will be 3. Okay, notice that this a is greater than 1. All right, and then if it's x is 2, it'll be what? 2, 3 squared. That is why we have what? 2, 9. And then on this side too, you have negative 1 over third, which is that negative 2, 1 over 3 squared, which is what? 1/9. Okay, so that's a graph. Now, when you have y is equal to 3 to the negative that, what does it mean? Because we replace what? The x with what? Negative x, which is a reflection in the what? In the y-axis. Okay, so we reflect this graph in the y-axis. Okay. So what is in the positive? They say the point 2, 9 becomes negative 2, 9. The point 1, 3 becomes negative 1, 3. And then the point negative 2, 1, 9 becomes what? Positive 2, 1, 9. And so that gives us this graph. Okay. Then you see that plus 1, that is what? A vertical shift. It goes up by what? By 1. So we have that graph, and then we shift it up. So it means that the horizontal axis will go up. Every point will go up by 1. So this point becomes what? 2, 1/3. This point becomes what? 3, 1/9. This point becomes what? 0, 2 in that order. Okay. So we shift it up, and that gives us that. Now from this graph, what is my domain? You see, it's still all real numbers. My range is what? This is from 1, because now the horizontal asymptote is not 0. It is what? Y equal to 1. So the range is from 1 to positive infinity. Then that's my horizontal asymptote, is the line y is equal to 1. And then the y-intercept is what? 0, 1, 0, 2. Because everything shifted up by 1. Okay, let's go to the next. Let's define the number E, because it could be a base. All right. Now, one thing you've got it before we go on. The graph of an exponential function, it's what it is, 1-to-1. Now, what does it tell us? If it's 1-to-1, then it's going to have an inverse. Okay, you're going to have an inverse function. So the inverse function we'll talk about in the next section, 5.4. All right, that's a logarithmic word functions. So let's define the number E. The number E is defined, that's a definition. So if we have 1 plus 1 over n raised to n, and then we pick the values for n, and then we increase it, let's say if it is 2, and it goes on to say 1,000 or maybe 10,000, in that order. All right, what happens to what this expression? It approaches a certain value. Okay, in calculus, we say n approaches in positive infinity, and then we say the E is equal to this. In fact, this E will approximate a certain value here, which is approximately, all right, that's E raised to 1, or approximately what, 2.7 1828, and then 1828. So this is the value of what? This is what this value, this expression. Okay, you can try it using the table. You increase the what? The ends, increasing by 1,000 and 10,000 and all that. You could see that this, and evaluate this function, this expression, and you always get what? You approximately, it will approximate what? This value, 2.718, like that. 182.8, 182.8 in that order. Okay, so it means that we can, because we have an exponential function, say of the form e raised to x. So when you see e raised to x, this is the value of what? This is the value of e. It continues, all right? It doesn't stop. It's a repeated what? Expression. Okay, expressed decimal. All right, so let's look at the function. We'll try and graph the e raised to what? Okay, the base, remember the e, the value is greater than 1. So it behaves like a is greater than 1. All right, so a is greater than 1. It's going to be an increasing function. It's going to pass through the same points. All right, and then 1e, and then -1 is what? -1 over what? -1 over e. And if it's -2, okay, if I add the -3 there, this is going to be what? E raised to what? Is to the third. So this, the point at -3, the point there is going to be, have the coordinates -3 and 1 over what? E to the third, like that. So that's how it behaves. It's an increasing function, and it goes to these points. All right, now let's use a transformation to graph this function. F of x is equal to negative e raised to what? X plus what? X plus 2. And determine the domain, the range, the horizontal asymptote, and then the y-intercept. Right? So as you can see, if it is negative, the base function, all right, your base is what? Y is equal to, y is equal to e to the x. And then if you have negative, that's a reflection in the y-axis. And then if you replace the x with what? X plus 2 is going to shift to the left 2 units. Okay, so we have the base function. Okay, got the base function as we have graphed it. This is it. Okay, and then we what? Because it's negative. Okay, y is equal to negative of that is a reflection in the what? In the x-axis. All right, so you have this, we reflect this in the x-axis. What happens? This point becomes 0, -1. Okay, 0, -1. This one becomes what? 1, -e. This point becomes 2, -e to the squared, and so on and so forth. So we reflect it in the what? X-axis. All right, and then finally we have what? Replace this one, we shift it to the what? Left 2 units, and that gives us what? This graph. Okay, so that gives that graph. So if you reflect in the x-axis, these are the coordinates that we just talked about. Okay, Is it decreasing? Yeah. Okay. So the domain of this is what? All real numbers. The range is now for from what do you call it? From 0 to negative what? Infinity. The horizontal asymptote is what? Y is equal to the line y is equal to 0 was a y-intercepted. It's what? The y-intercept in this case becomes what? When you f is 0, that's why we have this point, because we shifted it to the left. Okay. So y-intercept is when you plug in 0 for x, and then we got what? This point. Okay. So that's e squared negative e raised to 2, and that gives us what? Negative 7.339. Very good. So now let us consider solving some exponential equations. Okay. So the property is that if a base, okay, a raised to u equals a raised to v. Now, if the bases are the same, that means that the exponent also the same. So that is why we have u is equal to what? V. And please, the u and v are not numbers. They are combination of numbers and other variables. So we can equate it and get what? And solve that equation. It could be linear. Sometimes it could be a quadratic function. And even sometimes it could be polynomial. Okay. And then if we have done solving polynomial functions, then we can do that. All right. So let's take some examples. Solve each of the exponential equation. Now, a, 2 raised to what? X plus 2 equal to what? 8. Now, as you can see, 8 and 2 are not the same. But for us to apply the property that we just talked about, they must have the same base. And thankfully, we can write 8 as what? 2 raised to the third. Okay. So this is equal to 2 to the third power. And you have 2 to the what? X plus what? Plus 2. Now, since now the bases are the same, we can say that x plus 2 is equal to what? Is equal to 3. The exponents are the same, are equal. And so when you solve for x, you get 3 minus 2, which is equal to what? Which is equal to 1. Okay. All right. So like I explained, I'm just saying that what I have there, let me erase that so that you can see that well. Okay. So basically what we have done is I've just repeating myself. So this is a 2 to the x plus what? Plus 2 is equal to 2 to the what? To the third. And then we equate the exponents. So what's the solution set? Okay. The solution set is that you have what? X is equal to 1. So this is what is a solution set. We can check. Okay. It's always good to check your answer. Checking this, that is x is equal to 1. So let's do 2 to the what? 1 plus 2. Is it the same as? Is the same as 8? Of course, you get 2 to the what? Third is equal to 8. And that is what? That's check. Okay, so the solution set is what? Is 1. All right. Now let's consider the second problem. All right. Now again, we got 9 and then what? 27. You cannot express 27 as a multiples of what? As a certain power of what? 9. But we know they have a common factor, which is what? Which is 3. Okay, so I'm going to write the 9 as what? 3 squared, all raised to what? 2x minus 5. And this is equal to 3 to the third, which is raised to what? X. Because 27 is what? 3 times 3 times 3. And then 9 is what? 3 times what? 3. Because before you can use the property, this must have what? The same what? The same base. All right. So then, using one of the properties, the laws of exponent we talked about, This, the left-hand side become 3 raised to what? 2 times what? The exponent, which is 2x minus 5. And this is equal to the same thing, 3 times x be what? 3x. Now the bases are equal, so therefore we can equate the what? The exponents to be 2. So that means we got 2 times 2x minus 5 is equal to 3x. Now let's multiply this to be what? 4x minus 10 is equal to what? 3x. And then subtract 3x from both sides. Okay. This is equal to 0. And this is x minus 10. And you get what? X is equal to 10. So we can check to make sure you have what? They are equal. You get what? 9 raised to what? 2 times 10 minus 5. Is it the same as 27 raised to 10? Okay, you got 9 raised to what? 20 minus 5, which is what? 15. And get 27 raised to what? Raised to 10. Like we did, we're going to write it as 3 squared raised to what? 15. And then you get 3 cube raised to what? 10. So that gives me 2 times 15 is what? 30. So you get 3 to the 30. And then this side is what? 3 to the what? 3 times 10 is what? Is 30. Okay, so this is what? This is check. All right. And then the next example, it involves what? The e. All right, you have e raised to negative s squared minus minus x, e raised to minus s squared equal to e raised to 5x times what? 1 over e raised to what? To the 6. Now first, for us to able to add the exponents, we have to take this one up and write it as what? E raised to a negative 6. All right, so let's do that. So the left-hand side becomes e raised to negative x squared, and they have e raised to the 5x times e raised to what? Negative 6. Okay, so now they have the same base, so we can add the exponents. That would be e raised to what? 5x, okay, minus 6, and then e raised to what? Minus x squared. Now look at the equation. They have the same base, e, so we equate the exponents. So this means that we have for minus x squared, okay, is equal to 5x minus what? Minus 6. Okay, so then this is quadratic. So we bring everything to one side. We get what? Minus x squared minus 5x plus what? 6 equal to what? 0. Okay, then if you multiply through by what? Negative 1, you have what? X squared plus 5x minus 6 equal to what? 0. Now let's factor this. We have x squared minus 5x plus, sorry, plus and minus. Okay, minus equal to what? 0. So what are the factors? Okay, it'll be x plus 6. So x minus 6, and then x plus what? Plus 1. X minus 6, x plus 1. Okay. Okay, x minus 6, x plus 1. So if you set each of them to 0, or x plus 1 equal to 0, you have x is equal to 6, and then x is equal to negative 1. Okay, so what's my solution set? Okay, the solution set is that now you always have to check before the solution set is what? Will be minus 1 and then what? 6. Okay, now you need to check before even write down your solution set, because you can have extraneous what? Solution. Okay, when x is equal to 1, and when x is equal to 1, if I take x is equal to, sorry, negative 1, I have what? E raised to a negative 1 squared. Is it equal to e raised to what? 5 times negative 1, and this is to what? That. Okay. All right. So you have for e raised to This is negative, negative. So by negative 1. And then you have e raised to what? Negative what? 5 times e raised to what? Negative what? Negative 6. Okay. So let's check that. You have for e raised to negative s squared. That's negative 1. And then fx is what? X is going to be 5. So they see that this is equal to negative what? 11. Okay. And this is what? E raised to what? Negative 1. Okay. Now, as you can see, they are not the same. All right. Then let's check for the other one. X is equal to what? X is equal to 6. You got E minus 6 squared. Okay. Is it equal to E raised to what? 5 times what? 5 times 6. And then E raised to what? Negative 4, negative 6. Let's see, did I do this right? You got S squared is minus and this plus. Let's go to that. S is equal to 6. And then S plus 1 equal to that. Okay. So you get E raised to 30 times E raised to minus 6. Yeah, so that's another. This is supposed to be, actually this is plus and that is minus 1. Okay, I got it backwards. So this is plus, that's minus 6, and that is positive 1. So that is 1. The solution set supposed to be, I got that messed up there. Okay. So this is a negative. It is x is equal to negative 6, and then this is positive 1. That's positive 1, right? So you go here. That's supposed to be minus 1. Okay. All right. So the solution set is what? It has to be negative 6 and then 1. Okay. So if you check this, then that should be correct. Okay. Like I said, we should always check before we what? We write down with the solution set. Okay. Okay. So x is equal to, let's do the negative 6. So you have e raised to negative of what? Negative 6 all squared. Okay. Is it the same as e raised to what? 5 times minus 6 times e raised to what? Negative 6. Okay. This will give me e raised to a negative for 36. And that is equal to e raised to a negative 30 times e raised to negative 6. And that gives me e raised to negative 36. So that is check. And then when x is equal to 1, you have e raised to a minus 1 squared. Okay. Is it the same as e raised to what? 5 times 1, and then e raised to negative 6. So that is what? E raised to negative 1 is equal to e raised to 5 minus 6, which is what? E raised to minus 1. That is check. Okay. And then finally, this is an application. It's a healing of wounds. All right. So it said the normal healing of wounds can be modeled by an exponential function. If A naught represents the original area of the wound, and if A equals the area of the wound, then this function is given. That's A is equal to A naught times e raised to a negative 0.35 times n. Okay, where n is the number of days after following an injury when no infection is present to retard the healing. Okay, that is it. If there's no infection, all right. Suppose that the wound initially has an area of 100 square millimeters. Okay, if the healing is taking place, how large will the area of the wound be after 3 days? So here in this case, Your A naught is what? 100. And then your N is what? Is this 3. Okay, so the solution is that we just plug in A is equal to, evaluate this is 100, and then E raised to minus 0 0.35 times what? Times 3. Okay, now we have to evaluate that. Okay, put there. Okay, if you use your calculator and evaluate it, we should get a very good answer there, which I've done it here. So I wanted to. So when you evaluate this gives me, okay, you get 100 times 0 0.3499 377, okay, which is actually 34.99. So approximately, okay, approximately this is what, 35 what millimeters or square millimeters. And that's the end of this video. I hope this is helpful, and sorry for the mess up with the solution there, but it is okay. I corrected it immediately. Thank you, and I'll see you next time.